Roger, Columbia rolling.
A booster rocket uses every bit of its fuel just to carry its payload beyond the effects of Earth's gravity and protective atmosphere. Once in orbit, a spacecraft can travel thousands of miles per hour without any hindrance from the friction of air. There is no air, no atmosphere, no wind noise. It takes a lot of high-tech research and engineering to put astronauts in space, and most importantly, to bring them back. Behind each space mission are thousands of highly skilled engineers and technicians. They work together toward the common goal of space exploration and technology advancement. Like the space program, the automotive industry uses a vast, highly skilled team of engineers and technicians to design, produce, and maintain high-technology cars for today's fuel and safety-conscious drivers. Now, as in the past, Buick is incorporating technology and developing systems that will launch us well into the 21st century, as here at the Aerodynamic Laboratory of the General Motors Technical Center. Hi, I'm Jack Lausma. As an astronaut and a pilot, I'm well acquainted with the effects of wind noise. As an engineer and educator, I work with high-tech airfoils that are designed to overcome air resistance both on the Earth and above it. As a Buick technician, you are a pivotal part of this high-tech team. You are the person who provides the critical connecting link between the finished high-tech product and the public for whom it has been produced. You, like an astronaut, have to keep up with many new and sometimes complex systems and procedures. That's the challenge. In each profession, automotive and aerospace, the more you learn, the more efficient you become. This Buick know-how is understanding wind noise. We're going to explore three main areas in this program: what causes wind noise, the various types of wind noise, and procedures for diagnosing wind noise. Let's start by looking at something we can't see: air. We live in a sea of air molecules. Although we can't see air, we can feel and hear the effects of it. As a car travels down the road, for example, it runs into air molecules and pushes them out of the way. The faster the car goes, the more air it displaces. The shape of the car determines how much air resistance it encounters as it moves. Some vehicles use up to 50% of their fuel energy just to overcome air resistance. Research engineers used wind tunnels to recreate the airflow over a car's body. Instead of the car moving, it's the air that moves. At this GM wind tunnel research lab, large wooden blades force air across the vehicle surfaces at air speeds up to 150 miles per hour. Smoke is used in the airstream so that engineers can see how the air moves around the vehicle's body contour. The airflow disruption is extensive on this bus. The result is excessive air turbulence around the vehicle. Turbulence creates a dead airspace or envelope around the body. The envelope acts as a noise cushion. The larger the envelope, the less wind noise noticed in the passenger compartment. Scale models are often used with today's use of computer-generated designs. But modern passenger cars are more aerodynamic. The air passes over this car body much easier than it did over the bus. This design slips through the air more efficiently, using less fuel. However, with less air turbulence, there is also a much smaller dead air envelope surrounding the vehicle. Most front-wheel drive cars have less than 1.5 inches of dead airspace. This streamlined effect is known as laminar airflow. Laminar airflow, combined with the car's pressurized ventilation system, can make wind noises more noticeable to the occupants. As the air flows around the car, some of it strikes the windshield and is redirected through the vents into the interior, pressurizing the inside of the car. The air passes through the passenger compartment and out through the pressure relief areas located in the quarter pillars. This creates high pressure inside the car. At the same time, exterior air rushing past the windows creates a low pressure area. The combination of interior high pressure and exterior low pressure tends to push door glass away from the weather-stripped ceiling surfaces. If any weak spots occur, air leaks will result. And, you guessed it, wind noise. Wind noises can be classified in two basic ways: location noise or sound types. There are three basic sound types: wind whistle, wind roar, and wind rush. Wind whistle is a high-pitched sound and is usually caused by air escaping from the vehicle interior through a defective seal to the outside. Wind roar sounds like someone blowing over the top of an empty bottle. It's usually caused by outside air passing over an opening, such as a misaligned body panel. Wind rush is a whoosh that occurs from air passing over the vehicle's exterior. As a technician, in addition to understanding wind noise types, you need to be able to determine their location. Are the noises from inside or outside the vehicle? When the ventilating fan is on, an internal noise will occur at all times at varying levels, whether the car is moving or at rest. Most of the time, air leaks are the cause. Many internal noises are repairable. An external noise occurs only when the vehicle is in motion. An external noise indicates that air is moving around an object or changing direction to cause the sound. Very few external noises can be eliminated. Anytime complex diagnosis or repair procedures are performed, the use of systematic steps, such as found on a checklist, are a crucial part of successfully completing the task. I should tell you that in flying the space shuttle, the astronauts always use checklists for not only normal procedures, but for systems troubleshooting as well. It's important to follow a logical procedure. This diagnosis flowchart is a guide for verifying, locating, and analyzing various wind noises. Of course, it's a good idea to begin by getting as much information as possible from the customer. The customer comment worksheet helps you and the customer communicate effectively about the nature of the complaint.
Okay, I need to ask you a few questions before we take it on a road test. Could you tell me where the noise occurs?
Seems to come from
Ask the customer to describe the sound.
Does this happen at the same speed?
Yeah, it doesn't seem
Find
to
out
matter.
under what driving conditions it is most
noise level
noticeable.
increase the faster you go?
No, I don't think so.
No. Okay. How about with the air conditioning on, or heater, or defrost?
No?
No.
If possible, it's a good idea to have the customer go along on a short road test
Conditioning
to
on,
help
and
verify the
it's rolled
complaint.
up also.
Okay.
A thorough road test is critical in verifying and locating the source of the complaint. For a more efficient diagnosis, it's a good idea to have a helper drive the car while you listen for wind noise. A mechanic's stethoscope or electronic listening device is helpful in locating air leaks around door glass. Turning on the climate control fan increases interior pressure and makes an interior noise louder. Rolling a window down and up helps determine noise origin. If the noise goes away completely when the window is rolled down, the noise is an internal one. If you can still hear it with the window down, the noise is caused by something on the car's exterior. Deciding if the noise is internal or external during the road test is important. This determines what type of visual inspection will be performed back at the service area. Let's look at the steps involved in isolating an external noise condition. First, inspect the exterior of the car, paying particular attention to possible misaligned body panels, such as door leading edges and molding strips. Also inspect the front end and grille area for protruding components or accessories. If you find any suspected sources of exterior wind noise, use masking tape to cover the components. Remember, if the grill needs to be masked, avoid a lengthy road test in order to prevent overheating. Then repeat the road test and listen for the noise. If the noise is gone, remove the tape from one component and continue the road test. Repeat this procedure until the noise returns. In this way, you can isolate the part that is causing the problem. At this point, you should be able to determine if the exterior noise can be repaired. Items such as a misaligned door or loose molding can be adjusted to minimize the noise problem. Refer to the proper body service manual for these procedures. Noises caused by air rushing past external components such as rear view mirrors or A-pillars cannot be repaired. Careful explanation to the customer about the situation is necessary at this point. Internal noises are treated a little differently. As with external noises, the first step when diagnosing internal noises is a visual inspection. The visual inspection mainly involves the sealing surfaces of doors, windows, and stationary glass. Door closing effort and window operation should also be checked to be sure these components are contacting sealing surfaces properly. There are some specific diagnostic tests that you can perform to locate internal leaks. Which ones you choose to do depends on the equipment available in your service department. The Know-How Reference Manual provides detailed instructions for performing each test. Let's take a quick look at each one. A bright flashlight or a shop light directed at sealing areas can help point out leaks. Any place the light shines through is a potential leak. Using a dollar bill or a piece of paper helps in locating areas where weather stripping is not sealing tightly enough. There should be a moderate resistance as the bill is pulled through the sealing area. The chalk test can help pinpoint small gaps in compression between the weather stripping and the door. Soft chalk or spray powder is applied to the weather stripped sealing surface. The door is closed gently but firmly, then opened and inspected. The weather strip mating surface should have an unbroken line of chalk transferred to it. Any skip areas of 1/8 inch or more should be considered leak areas. The vehicle air pressure test pinpoints very small air leaks. By sealing off the pressure relief valves of the car's ventilating system, you can increase the interior air pressure, which will make leaks easier to locate. Once the masking is complete, be sure all windows and vents are closed, turn on the ignition key and heater vent fan. Then listen for air escaping from around the door and window sealing areas. A stethoscope or electronic listening device helps locate any leak. You can also spray soap solution or glass cleaner around the sealing area and watch for signs of bubbles which indicate leaks. The compressed air test is similar to the vehicle air pressure test. This is useful for vehicles that have difficult to reach pressure relief valves. However, take care to limit air pressure to 30 pounds per square inch or less to avoid damaging any sealed areas. Also, a helper may be necessary. If available, a sonic tester is a helpful piece of diagnostic equipment. This unit consists of a transmitter or tone generator and a receiver. The tone generator is placed inside the car. It sends out a signal which is picked up by the receiver. The receiver measures the intensity of sound. You can determine where leaks are by noting locations of higher sound intensity. Each type of sonic tester is slightly different, and you should consult the proper operator's manual. As with external noises, once an internal noise is located, you must next determine whether or not the cause of the complaint is repairable. Many air leaks can be quickly repaired with simple applications of additional sealant or adhesive. There are many sealing and adhesive products from which to choose. Be sure to follow directions for each type. Your Know-How Reference Manual describes the various types and applications of sealers and adhesives. Naturally, there are some internal wind noises which cannot be repaired. In these cases, it's important to offer a clear explanation to the customer. Now, even with high technology research and testing, wind noise problems are bound to be with us for as long as we are surrounded by air. For example, a spacecraft must return to Earth sooner or later where it is affected by a protective atmosphere. But NASA's space team makes sure that astronauts are knowledgeable and skilled in flying back through the atmosphere. The NASA high-tech team deals with the challenges of spaceflight on every mission. You, as a member of the Buick high-tech team, are also well prepared to deal with the challenges of today's cars and tomorrow's.
The great American